onward to Module 5. You will love Chapter 5 if you like making decisions and you're good with logic. But I bet most of you are. And if you've ever had a coding class before, this is where we cover if statements, if else, and or nots, switch statements, while, all that good stuff. So, 2 new words maybe. Pseudocode is when you kind of use paper and pencil and show things in a programming's logic. For example, a pseudocode might be, if it's a beautiful day out today, I am going to have a picnic and cook out in the backyard, else get takeout. So that's where you kind of write that down so you can see what the logic and what to do and use everyday language. Or you can use flowcharts. A lot of companies still definitely use this as they go along. And there's also something called a sequence structure. It's where one step follows another unconditionally. So we'll take a look at some of these items. So here's a flowchart. This is, let's say you're trying to drive around, and first you need to go west on Algonquin Road, and then next you turn left on Roselle Road, enter expressway heading east, exit south. So it's when you kind of go through a series of steps, and that's what a flowchart looks like. First, we're going to head into a decision structure, and basically we'll decide if that decision is true or it's false, like it's a nice day. And don't forget from Chapter 1, that's called a Boolean value. It can only be true, false. Hey, let's zoom into this. So let's say you're making these directions, but let's say this is in Texas. I think they're in Dallas by the names of these roads. So you get on Roselle Road, you go to get on the expressway, but if it's backed up, go this way to get there. But if it's not backed up, go this way. And we call this a flow chart or a decision structure. If you notice, all the steps were put in rectangles, but the question that says, is this a nice day or is the expressway backed up is typically put in a diamond. This way if it's true, this way if it's false. So that flowchart can help, and a lot of times companies will draw these out to kind of with a very complicated app, maybe an app that checks out at Walmart. Can you imagine how many ways are there to pay at Walmart? Not just by cash or credit card, food stamps, gift cards, coupons. Can you imagine the decision structure then? So let's start out with the absolute easiest, and I'll show you some code in a moment. It's called the Ifs statement. And notice, if is lowercase letters. Once again, Java is case sensitive. And this is where I see a lot of students make mistakes. They use one equal sign. I don't know if you remember from the first 2 chapters, but we say, is this equal to? So when there's a double equal sign, that's always used if you're determining if it is equal to. Don't use a single equal sign. So let's kind of look at code that would go along with this flowchart. So let's say there's a quiz with 10 questions. We say if the quiz score out of 10 questions is equal to, did you see how I said that? Is equal to. I always read it in 2 different ones so I remember to do my double equal sign. If that's true, it's going to print out the score is perfect. And we could have written the same flowchart by saying it here. If quiz score is equal to 10, then if it's true, print out this. If it's false, well, we're not doing anything just yet. So, and be careful. This is a not screen. Don't do this screen. Do not put a semicolon at the end because it thinks that you're done with what's happening if it's true. It's like ending the thing. So no, semicolon at the end of the if statement. Yes, you can put it at the end of your print line statement, like the score is perfect. Be careful with those 2 things. Hey, next I'll show you some bigger code. So let's take a look at a code that has basically 2 single if statements. So what this is doing is we have int is reference of how many items you're going to buy, let's say at the store. Double is going to represent the price of the item that you're buying. And we have the standard price is going to be $11.22. Notice that's a constant. It's set to a final. Good to know for the test coming up. Final int low limit, you have to buy, I guess, at least 4 items. The higher price is $12.45 and the high limit is 12. The lower price is $9.77. So we've got all these variables assigned. And then we're going to be asking for input. So there's our system.in. And here is our system.out print. How many items do you want to order? Now everybody, let's look down below. How many items do you want to order? Now notice there's a low limit of 4. If you do 4, you get, I guess in this case, we'll find out in a second, but you'll get the higher price if you only buy 4 because you didn't buy enough. And then if you buy a lot, you get the lower price. And so let's see how this would roll. We're coming down to line 15 and it's saying grab the value that you put in and assign it to items. So what I'm going to start off with is I'm going to buy 20 items, okay, to get started. When I hit enter, it said the price of each will be $9.77 each. Let's figure out why that occurred. Everyone now, it took standard price, SDR price, remember that's $11.22. It assigned it to price. And it said if the number of items, now remember we put in 20, if 20 is less than the low limit, let's go look, the low limit is 4. So is 20 less than 4? No. So we're not going to do line 18 because it was false. So now we head on to line 19. Let's compare this one, another individual single if statement. If the items, once again it's 20, is greater than the high limit. Let's go up here. Ooh, it is. 20 is greater than 12. So in other words, we bought so many, they're giving us some kind of discount. And we come down to here and the price is this lower price of $9.77. So let me run it again because I want you to get the idea that you're going to get different output. Let's say I'm only buying 1 item and I hit run. Do you see that the price will be $12.45? Why? That's the higher price because, let's see logically why. 1 is less than the lower limit. Oh, so line 17 was true this time. So that's why we paid the higher price of $12.45. Let me run it again because we're still missing one of the logic pieces. And make sure you always run this many, many times to make sure all your values do whatever you expect them to do. So for example, let me now type like 10 items, okay? So I wonder what would happen if 10. So now when I hit 10 here, hold on, make sure I get 10 in there. It's $11.22 each. So why $11.22? Remember, the standard price was assigned to price. So if 17 and 19 aren't true, so let's double check this. Is 10 less than 4? No. So line 17 is false, so we do not do line 18. Let's look at 19. Is 10 greater than our high limit of 12? No, 10 is not greater than 12. So that's false, so we do not do line 20. So therefore, when we get to 21, price is still the same value from line 16. That's $11.22. So basically, if you buy less than 4 items, 1, 2, or 3, you pay the higher price of $12.45. If you buy between 4 and 12, you pay the price of $11.22. And if you have more than 12 items, then $9.77. Now be careful. What would change if I do less than or equal to? By the way, that's how you do less than or equal to or greater than or equal to. I'm going to run it again, but I'm going to put in the tricky number of 12. Let's see what happens here. So let's go here. Are 12 items less than or equal to the low limit? Nope, it's not less than, so we don't do line 18. Let's go to line 19. Is 12 greater than or equal to the higher limit, which is 12? Yeah, 12 is greater than or equal to 12. So we get the lower price of $9.77. So it's an amazing what a less than, equal to, or a greater than, equal to can do to change your logic. So this code, instead of just having a single statement, if statement, if it's true or if it's false, let's get into a multi-line if, and then also the else. Back to my original. If it's a nice day today, let's go have a picnic in the backyard or cookout. Else, if you would, let's get takeout. So let's kind of look at this one. Now they switched the numbers on us. Oh, well. But the high limit is 12. The standard price this time is going to be $44.66. The lower price, I guess if they buy more than 12, is $38.77. So we have our in and our message. How many items do you want to order? And that's going to be assigned to items just like in the last program. So I'm going to come down here and pick 13 items. So I'll hit enter. It says you ordered enough for a discount. The price will be $38.77 each. So what happened? Well, everybody, let's pick up in line 15 here. Now, nice and big. So if 13, remember that was what we typed in for items, is greater than or equal to the high limit. The high limit is 12. So, oh, that's true. Instead of just doing one line like we did before, we're going to do more than one line. So first thing you need to know, include opening and closing braces in your if statement if it's more than one line in length. And this is more than one line. It's 2 lines. So I'm going to include that. So what's going to happen is the lower price, $38.77, is going to be assigned to price. And I'm going to go ahead and make them feel good. You ordered enough for the discount, so maybe they remember to buy more next time. And by the way, it doesn't print there, but it does assign to print price and message. Else, now let me make a point before we move on. Make sure it doesn't print there unless you really need it to, because then you need a lot more print statements. If you had to have print statements in the if and in the else instead of one, always think when you write code, how can I write the least amount of code that's most efficient instead of having more lines? So now let's say items wasn't greater than 12. Let's say I run it again and say I just want one item. Well, 1 is not greater than or equal to 12. So here's the logic here. If this line, 15, is false, it goes to the else. And else typically is all by itself, although if you put this brace to the right of it, it's fine as well. I like spreading it out like this though. And so if this portion is false, it does the else statement. So now we come down to the else. It says now we're going to assign the standard price to the price, which is $44.66. And we have a cute little item. If you ordered, ooh, what is this doing? Look at this. What this is doing is saying, okay, the high limit was 12, if you remember. If you subtract the one item, remember, 12 minus 1, it would say if you ordered 11 items, or 11 more, you could qualify for a discount. So nice little message there. And then 26, after we complete this else, it just continues on with the rest of the program. Line 26, it prints the message. It's either going to print this one or this one. It's either greater than or equal to 12 or not. So it's going to print one of the two messages, and the price will be and tell what the price came out to be. So let's run it one more time to prove it to you. So now if I run this code and put in 1, oh good, the price really will be $44.66. And if I order 11 more, I could qualify for the discount. Cool. So let's talk comparison operators. You've already seen less than or equal to. We had greater than, I can draw here, greater than or equal to and greater than. So we have 4 so far, but there's 2 other ones. We have the double equal sign. If statements cannot use a single because an equal sign by itself assigns a value like A equals 3, single equal sign. But in an if statement, you have to use 2, is equal to, so don't forget that. But let me show you not equal to. Now I know When you were in younger grades, you probably did something like this for not equal to, right? Well, if you notice, that's nowhere on the keyboard, so that's going to be a problem for us. So in Java and several other programming languages, we're going to make a not, that's an exclamation point, and an equal. That exclamation we often read not equal to. So exclamation in most programming languages is a not sign. So exclamation equal means not equal to. Now you can't have an else without an if, but you can have an if without an else. Let's look at a single one-liners each. So if the quiz score is equal to 10, you're going to get the score as perfect. Else, it's not perfect. And you can kind of see the flow chart here going in the right directions. I didn't need braces in this one because it wasn't more than one line, whether it's true or whether it's false. So if you are executing more than one statement within the if or if-else structure, you need to use a pair of curly braces and place any dependent statements, whether it's true or whether it's false, within the block. And it's crucial to place the curly braces correctly. Don't have them overlaid like, not working well together. So for example, if you were to put this statement in, and this is a common problem, by the way, this is under the don't do this. If you have something like the hours that you work are greater than a full week, let's say a full week is 40, you would have regular pay equals full week. And then here's a second line. What happens here, it would run, it would not throw an error, but now you have a logic error. In other words, it's not what you thought it would do, and it's going to do something wrong. What this is going to do, since it's more than a single statement, it's going to just do this first statement, and regardless if this is true or false, it's still going to do this overtime pay, regardless if it's true or false, because it's just continuing on with the rest of the program. So if you wanted these two lines to only happen if it were true, there needed to be a brace before regular pay, and at the end of rate, semicolon on the next line, a closing curly brace. We can have nested if structures. Be careful when you're using nested. I'll show some of these, that they don't get too complicated, that you have everything put together. Here's what I mean by a nested. It's two if statements that you're making sure that both are true. So if it's true that the item sold is greater than the minimum items and the total value is over the minimum value, then you get the sales bonus. So notice here we have two if statements. The computer would need true statements must be true for the bonus assignment to be made. So in other words, this one must be true, this one must be true for this line to happen. So we call these nested, but as you can probably see, they can get a little confusing. We also can use a logical operator. A logical operator, the two most common are and or. And listen to this sentence. Today, if it's a nice day and my family comes over, then we're going to have a cookout out back. Else, let's get takeout. So I have two things going on with an and. Both, it has to be a nice day, and both have to be true, and my family has to be here for dinner. So both of them has to be true. Now when you say or, only one has to be true. So how do you write some of these statements here? What we're going to have with several of these, let me go ahead and show you what they're going to look like. The and word, do not type in and. Instead, in Java, we put two ampersands. I know they look like and symbols, right? But you put two of them to say this must be true and this must be true. In other words, both of these must be true. You say, well, what happens if only one is true? It doesn't do the bonus. How about if none are true? It doesn't do the bonus. So when you use and, everything must be true in that line. There's also the or statement. It's like saying, well, if it's a pretty day today, or if my family comes, I'm going to have a cookout in the backyard. Else, let's have takeout. Only one of those needs to be true. So if my family comes and I'm going to eat out back, even if it's a terrible day, that's what that means. And if it's a nice day, I'm eating out back, whether my family comes or not. Only one has to be true. Now, we use what we call double pipes. Pipe, as far as on your keyboard, I want you to find after the letter P, there are 3 keys over. It's the top, it's like above the backslash. Look on your keyboard to find it. But you to put these 2 pipes together. 2 pipes always mean or. So in our code, here's what it would look like if items bought is greater than minimum items, or if item value is greater than minimum value, then do this if one of them is true. So let's take a look at some code. First, let's do an example of using and. Don't forget that's the double ampersands. So what we're going to ask the person in this program is how many years has an employee been on the job? A lot of times, companies do these, here we're going to give them some kind of bonus if they've been there so many years. So let's kind of look through the code and see what's going on here. We're going to have years on the job being integers, so it's going to be full years, no partial years. We're also going to give them a performance rating. A lot of companies give a certain number, and that would be good. Probably our performance rating is from 1 to 10. So final years is set to 2, we'll find out why, and the rating is set to A. Maybe if you haven't been there for 2 years and you haven't, if you don't have a performance rating over an 8, like a 9 or a 10, you don't get the bonus. So if you have a crappy rating or not so great rating and you've just been new there, you definitely don't get the rating. So we're going to ask the person, how many years have I been on the job? Let's say I've been on the job 5 years. So I'm typing in 5 years. And the next question that it asked me is, what was my employee's performance rating? Let's say I got a 9. So guys, I worked 5 years. I got a 9 for my performance rating on a scale from 1 to 10. So notice right here, it's assigned to years on the job, my number 5. It assigns my performance rating to 9 is assigned to performance rating. So everybody, all the money is on line 15. Let's really look at this. So if the years on the job, now the years on the job for me is 5 years. If the number 5 is greater than or equal to years, that's 2. So let's think, 5 greater than or equal to 2. Come on, say the word out loud. Come on. Did you say true? I hope you did. True. It is true. So this part's true, but it doesn't mean we continue on. Both have to be true. And by the way, you can use multiple and statements. You may have 10 criteria. So 10 different items all put together with these double ands, separate ones. And then the performance rating is greater than rating. So mine was a 9. Is 9 greater than or equal to 8? What do you guys think? Yeah, it's true. So now we have 2 trues. So yes, we go into line 16. Now, why didn't we need braces around line 16? Because it's a single liner. It's cool. So it's going to hopefully tell me when I hit, let's see, when I run this thing, hopefully when I hit enter here, it's going to say that I get this bonus. Oh, it does. Bonus is awarded. Do you see that? But let's say one of these wasn't true. Let me run it again. And let's say I've been there 1 year and I got a 9 again. What will happen? Well, 1 is not greater than 2. So it's going to go down to this else statement and print not qualified for bonus. You must have at least 2 years on the job and a performance rating of at least 8. Let's see if that happens. So now we put in, once again, 1 and a 9. And let me scroll down here. Not qualified for bonus. You have to work at least 2 years and a performance rating of at least 8. So the question is, what would happen if I work there 2 years? So now let's say I run exactly 2 and I have a performance rating of 10. So, yes or no, am I getting the bonus? Look through the logic. I'm hoping you are saying as you're watching this, let me hit enter. Yep, you do get the bonus. Why? Because 2 is greater than or equal to 2. And of course, the performance rating 10 is clearly greater than or equal to 8. So that's how it works. So now same program, but there is one itty bitty little change. I have changed line 15 from a double ampersand, which meant and, to 2 pipes, which mean or. Wonder if that'll change anything. Well, let's run it and see. Let me now put in one of the statements. Remember, I was on the job 1 year. Remember before, if I was on a job 1 year, it wouldn't work. But I got a performance of a 10. Let's see. It says my bonus is awarded. How is that possible? Let's go look. If I've been 1 year, 1, is it greater than or equal to years, which is 2? No, that's false, right? But in an OR statement, only 1 has to be true. By the way, they all can be true as well. Let's see if this part's true. My performance rating was 10, and that's greater than or equal to 8. So as long as one of these, at least one, in line 15, it prints the bonus. So ORs can trump everything. So be very careful in your logic when you're writing the code that you have the correct one. Do I really mean and, or do I mean or?